I'm going to get going. My focus today is going to be on the specific 3D software. Last session, I've done four sessions on each area, and the last session was basically whole program and how I use 3D printing and 3D modeling software. This one, I'm going to focus on just the software through the whole time to give a little bit more in-depth on it. If you go to steammakers.education, if you type steammakers.education, that brings you here. Everything that I've done is here already. So if you hit Steam Makers Professional Development, you look through, the first one is there, collaboration. That's basically how to build with cars and boats. When I do this with my younger grades, then Legos is all in here, and how to communication and digital asynchronous grouping is here. And then production is learning from failure, how I do the skateboards and how we work on that. And the last one I just did was designing from necessity, and it was around 3D printing. And now I'm going to do more specific on the 3D printing itself. Basically, what I'm trying to do is kind of show you today. When I do my presentations, I try to focus on really practical tools. I do the overarching, how it fits STEAM, science, technology, engineering, art, and math, and then the overall concept. So learning from necessity, design was the last one, or prototyping. And then I focus on a tool, a class management tool, and then a physical, I like a tool to use. So after getting done the last one, I realized I really needed to do one focus just on the tool itself. So from the last one, learning from necessity, we basically do the design process. We're focusing on creating functional prototypes, and my students do a make or take model. So basically they make something for the school, maybe a teacher pass, or we've had like a table, the legs broke, so there was a plastic piece they made, and they earn themselves print time. And in this, we've added scale and tolerances. When I do my younger 5th and 6th and 7th, 5th and 6th, the project doesn't really matter. The Lego you built, it's not really, until they do the challenge, it doesn't really matter what they build. Then 7th, you have the skateboard. If they drill the hole wrong, they have an extra board, but it kind of adds a little bit level. Now we actually, the teacher cares about the pass, or this piece actually has to fit whatever we're fixing. So I try to stay platform agnostic. So what I'm going to talk to you is usually works web. There's a PC version, there's a Mac version, or there's an equivalent software version that's out there. I'm not really trying to sell a program. This is what I use. There's other versions, you might like something. And there's that management issue, the software that you make it with, and then kind of products to produce with, the printers, things of that nature. So today I'm going to focus on Tinkercad, and I'll come back and I'll do a session on SketchUp alone next time. But Tinkercad is what I use to make 3D models, the kids to make. And I'll also talk about where you can find models that are already done that they can edit, and you can do the edit in Tinkercad as well. And then we're going to talk about slicing software, Flashprint, Cura, KiriMoto. Basically, the Tinkercad is how you make it, which any modeling software is going to have similar characteristics. And the same thing with the slicing software, whether you use Flashprint, Cura, or KiriMoto, they're having similar setups. And that's kind of what I'm going to focus on. Starting with Tinkercad. So Tinkercad.com, if you click and you go into it. Now, Tinkercad has some cool things with it now. You can actually create a classroom and put students in the classroom. So you basically create a classroom, and in it, so you see this class link, you can give it to the kids. You can add the students, like in emails, and just add the kids, and then give them nicknames or whatever you want, or give them the link and they'll join in it. It can, in class, if you have Google Classroom, it can connect to there. But what's kind of cool about it is, so you can set up a class, like I created this 3D printing class, and then I can add students. But in activities, I can click on it and I can say new activity, and I can say, tutorials, and I can pick like what things are going to be in there. So this tutorial, you can see I put in a design to let the kids tinker this, or you can see tutorial. So I can click on this, and you can see when the kids do it, that's cool. It kind of comes to you all in one spot. I also use Google Forms for collecting it, but this is a kind of a helpful way for you. So this place it tutorial that's in here, the place it tutorial that's out there, you can kind of grab and you can set it up for them. I just, it was helpful. You don't have to have it because the tutorials are right there. When you're in Tinkercad itself, Tinkercad has some great teacher ones. I'm just going back to start at the front so you can see. So if I, Tinkercad.com, I'm going to hit tinkercad.com, and you'll see, so you can tinker, 3D design, circuits, code blocks, sim labs. You can have a whole bunch of stuff here. 3D design, I'm going to do that. Circuits, you can teach kids circuits in here. Code blocks, you can make stuff, but it's like using coding blocks, like Scratch and stack it. Sim labs actually lets you create something and simulate a marble run, simulate how would the stuff move if I turn this on. And then the auto fusion desk, which actually they give is the high level. That's what my kids are doing CNC and making their guitar bodies that we do a guitar program, which I will present on that in a little bit. But gallery is finding objects that are already done. People out there make these objects already done for you. So I'm going to hit 3D design. So I'm just starting on a basic design. When you first open, it opens like this, right? And if you scroll down, you'll see that there are tutorials built right in. So if you scroll down, you do the get started or the more tutorials. So if I hit more tutorials, you'll see I have my kids do these 12, the 12 basic ones: place it, view it, move it, rotate it, size it, group it, copy it, duplicate it, hide it, align it. I do have them do creating holes because that's not in the first, and you can have them do the other. So if you have kids that get way done, say, okay, add these new ones. In the end, I do have them do this keychain, and I will show you this. So all these previous tutorials, if you click on, let's say you click on place it, you can add it to your class activity. So if I hit start, the kids can do this. I have my 8th graders do this on their own. So this tutorial on the left, it shows them what they're supposed to do. When they hit next, it shows them, okay, here on the work plane, it shows, okay, this orange, you need to get a box. It gives them a hint and kind of show them. So it says, okay, so find your box. Oh, there's a box here. And if I drag this over, and it says, oh, drag the box over and drop it right in here. And then, okay, I've done that. I hit next, and it will do this. Yay! Now, then it gives higher level ones, different things that you did. So that's the tutorials, and you can tell the kids, you take the kids through it, and the kids just do the basic tutorials, the first 12, okay? Now, once I have them do that, so I have them do a basic, and I can just do my own. I'm going to do a quick tutorial for you guys, but without, so I'm just going to start tinkering. Give me a second here. And if you go designs, I'm just going to create a blank design, a 3D design, and I get a blank. Here's the basics of it. Doesn't matter whatever software you're going to work on. Here is the work plane. Now, the work plane, you're going to have some way of spinning it around. Now, I'm using a mouse now, so my scroll button becomes my zoom in and out. If I hold it down, it moves. My right click will do different things, open menus. I can also, with the students, it's pinch. So I'm pinching on the keyboard. I'm using shark bite to go back and forth for zooming. If you hold the control key down, so I'm holding control key and I'm moving my mouse around. So the kids will do that using their touchpads if you have them in laptops, or if you're a touchscreen will do the same thing, but you're using it with your fingers. But you can see over here, you can see I could zoom around. I could see, so I have top, I'm looking straight down. I'm going to the front. If I scroll, I'm going to the right. Home will bring you back to that original kind of where you're looking away. The thing about working in 3-dimension, and this is hard for adults and hard for kids are used to computer games that lead them everywhere they go. So they're used to that. Now, they do play in Minecraft, and the one thing that happens, and we'll talk about this later when I do my presentation on SketchUp, but you can zoom so far out or you can zoom so far in, you can get yourself lost. So because you can be inside an object. So there are always, a lot of these programs will have like a reset, bring you back to home. So plus, minus. This shows like, so I just switched to straight down view. I switched to orthographic, which is like at an angle, and I can always hold and spin it below. So that's something you need to get the kids to understand. The other thing that happens is the kids got to start to understand there is a top and a bottom, and you can build objects. So if I grab a square and I shove it down, I can have an object that is underneath. And when you get ready to do printing and stuff, that does matter. That's first thing. On the right-hand side, you'll see different objects and shapes they give you to start with. Okay. And you have these kind of striped gray ones, and you have solid ones. Okay. So I'm going to spin this. So we're looking straight. Actually, I'm just going to get the home view so you're looking straight down. So I've got this box. If you click on the box, you'll see up here on the right-hand side, a little menu pops up for it. And if you push it down, you can, I can change color of the box. If I say whole, what I'm doing is I'm making the box, it's going to be hollow. And you'll see when we have another object, you'll see, well, how you use that. But you can also, right within it, you can play around with the shape. So you can see, I've made that a circle, or I've rounded the edges. Just going to make the whole thing bigger so you guys can see it. So it's giant. I can make it longer or wider just by this, or these 4 corner boxes. You can see I can hand do it by the white corners. I can actually go up here and type, and it will do a number. And again, you can have it restrained. So if you make it taller thing, it stays the same, up to you. The radius, again, same thing. So if you wanted a rounded edge, so you can see I have a square, but I want the edges rounded, I can do that. Steps, what steps are is the less steps you have, the rougher it will be. The more steps you have, the smoother it will be. But that also means longer print time. But if you really want a good quality print, you get less step. But if you go less, sometimes too, if what you're trying to make, I'm making a diamond, or I want that shape. That would be up to you. But you can hand do it over here, or if I click it up, I can actually come over here and drag it and do it that way. Now, you see there's these 4 whites. So you can see I'm making it taller. And the kids learn X, Y, and Z in this. So it's not just back and forth, left and right, or horizontal. You got vertical happening. So you can see I'm changing it. If I do this, I'm actually doing the other side of it too. Because if you think about it, you've got surface here, side, back. You've got multiple surfaces. All right. Now moving, if you want to move the actual object up and down on the plane, I'm grabbing that it looks like a cone or teardrop, basically upside this cone, looks like this purple shape over here. Now watch, if I do this, you'll see I'm floating in the air. So sometimes you want to do that. You want to raise or lower it. So I'm going to push this back down and on the. Now, also what happens is you can combine shapes together. So if I bring this shape over here, and you can see I put it on this surface. So now if I print it, those would be together. I can click on this. I can do that same thing. I can shove it down into it. If I make this a hole, so we talked about now it's a hole, and then what will happen is that will actually hollow that out. Now, if I'm going to make this so that it's, I'm going to make it taller, and then I'm going to move it. Let me zoom out a little bit. Get home. There we go. I'm going to grab this and shove it down into it. And the reason I've done that is this is hopefully going to go all the way through this object now. So now it's going to go all the way through. I might have to make it a hair bigger to make it go all the way through. And I'll show you why I'm doing that in a second. So if I shove that down, grab again, sometimes you get lost in the, and I'm going to make this a little bit bigger too, again, same thing. Now what I've done is this, now it's hollow. Now you can see it's gone all the way through, right? Because if I group this, if I take and I drag my mouse and I highlight the whole thing, and up here I make it a group, you now see I've made a hole in my object. So now I have a hole in my object. Okay. Again, if you can ungroup it too, if you need to change that, that hole, see, you can kind of see my hole is in the wrong spot. So I can, again, drag it, highlight the whole thing, ungroup, up in the right-hand corner here, ungroup, and I can say, I messed up where my I got to click on that, click off, and click on just on the little circle. And I need to move it so it's like dead center. And now I'm going to grab it. Same thing, I'm going to make a group. And now I've made a hole in my object. If you don't go all the way down, you can make it so there's a hole, but it doesn't go all the way through your print too, your 3D object. The other thing that happens is if I'm going to ungroup this again. So I'm going to take this, highlight it, and I'm going to ungroup. You can also, where you put that in the object too matters too. So I see if it's on the side, same thing. If I highlight it and I group it now, you'll see I've made it like kind of notched on the side too. Now, I've talked about all the basic shapes. These three little arrows. So this arrow is spinning it on the side. This arrow is spinning it to the back. And down here, it's spinning it to the front. So you can change the geometry of a shape by using those three little lines. And that's the basics of that so far. And then over here, you can mix things. And you can see some cylinders. Okay, this cylinder is already hollow when I bring it over. But I can also mix in. So I can bring in a circle. And you can see it's trying to put it on the plane of where it's floating. Like this is floating in the air, but if I want to move it, so I'm putting it on into the object. Again, until I group it, you won't kind of see what it would look like as a 3D print. But there's tons of the shapes that are already done. Okay. You can, there's circles, stars, diamonds, the basic shapes. And if you mix them together, you can mix quite a lot of shapes together. Text itself, if you want, you can come over here, and what happens is they give you a text box. So if I go here and I change this, I can, again, same thing. I can change the height of it. Now I can do all of this by these, I'm around, bevel will round the edges of it. Just let me grab it. Yeah, so I'm like rounding it, segments. And again, if I grab these, I can still resize it and all that stuff too. So if and you can see, I need to raise this. I want to put this right on the top of my object, and I want to squash it. Now you can see depth-wise, I have it like really thick. And again, with kids, I have to talk to them about, oh, they'll send stuff like this to me going, it's all done, Mr. Kelly. And then we'll look and go, oh yeah, it's floating in the air. So they have to think three-dimensionally, not just two-dimensionally. It's a hard thing. This is not an easy thing for them to think about. So now you can see I've got it hanging off the edge. I'm going to yank it up just a little. So you can have text, all of that. These are the basic shapes that there. If you click, there's design starters, like numbers. So if you can bring a number over, and you can have different numbers built in. There's these, this is a shape that, there's tons of stuff like that. There's more shapes if you want. Design starters, vehicles and machines. So there's wheels that are already done. So if I want to put those in, so the kids can really kind of play around, hardware pieces, stuff like that, that's built in to start with if they want to. And again, this won't look like, until I group it, like those pieces are separate or separated out. So I'm going to group it, and I'll show you why I'm going to group it in a second. All right, that's basic so far. I'm not going to, okay. Now you can do some stuff with you playing with your work plane. Like this one here will give you, sometimes you need to know like your size. So I've added like basically like a square onto my thing, so I can tell what size. You can see it gives me all the dimensions. And what's cool is I can get right there and type. So sometimes you need something very specific size. We've been building rockets for the kids to launch pneumatic rockets. And the size of the tube matters. The size of the fins and the angle of fins matter. So the kids get in here and really kind of manipulate down the basics, like what they want. This is kind of, I have the kids they do the tutorials. And when they're done that way, when they get done and they're ready, I'm just going to dismiss, get rid of the ruler so it's not confusing. And they say, okay, this is ready to go. They will export it and they send it to me as an STL or an OBJ or so on. So I'm going to hit STL. I'm downloading a standard tessellation model is what it really calls. So I just down it. Now, Tinkercad will do weird names for take loss because they have so many objects. They always have weird names. If you export STL, it will come like this. So if I group this, right, it's going to come as all one solid color. It's not going to know that this is yellow, this is red, this was blue, this was purple. It's going to just be as one big block. And when you go to the printer, that's all that matters. Unless you have a dual extruder printer that can jump between colors or know to pause, it's not going to be able to do that. But if you hit export, that would be an OBJ. OBJs, when they come down, they go and give you not only just the slicing information for this object, but they give you all the coloration too. Now, you can export for laser and other things in SVG, but right now we're just doing for 3D printing. So all I did is I have my kids export that when they do it. So I'm going to go back and grab. So if you hit Tinker, I'm going to go grab, I have my kids, one of their real projects they do. So if I say Tinker, I say 3D design, and I scroll down to the tutorials, I have them do the first 12 tutorials. I have them do these tutorials on their own because it teaches them the basics. And then I do have them do this tutorial right here. Let me reset it. And they open this keychain tutorial up, and they make a teacher pass. Okay. So on the left, they tell you what to do. The kids follow on and they read what it says. It also kind of shows them an instruction. So it's showing, oh, make the word Kate. And it shows them how to grab objects. Oh, let me zoom in a little bit. So this, so if I, for example, I have them, they make teacher passes for the teachers. And they have, so this little tutorial is really good to start them on, teaches them how to manipulate the letters. Oh, Kelly, I have to have another. So I'm copying and I'm pasting another, so they learn that. And then, oh, we need another E. And we add a Y. Now, then they have to learn, oh, okay, like, and the teacher will be the customer, and I'll say, well, tell them what size you want it to be. You can see they have to look, and I'm like, well, guys, that L you have is way above everything else. So they have to like make sure it's proper size, proper, looks good. It's the right thing. Now we color code our passes, so our one grade is all one color, one grade's all another. So I have them say, okay, so we'll show it to them what it's going to look like. If the 8th grade's a red, I've had kids give like the eyelet here, and the eyelet wasn't like right size or wasn't touching. So those would print separate. So we have to talk to them about that. Again, if they click this and they say whole, and they push this into it, if it's big enough, that will be notched instead. Now we also have to talk about, if you have, now my name, that's not a problem, but if I take this, if I had an O in my name, well, yeah, this is great. But if you put this over here and you say that's a whole, well, when this prints, this little in between is just going to fall out. So there's stuff like that they have to figure out what would work, so on. Also, where these are going to be practically used, so they have to look at it and say, oh, if I have this, so if I have one of these letters like really tall, then what will happen is the kids are gonna go and pick at it and break it and that thing. Like just like as you saw, I resized this. You wouldn't want like something, you wouldn't want it too thick or not thick enough or that type of thing. So and what happens always is the kids leave the extra letters too, because when I'm done, like, hey, you got to get all of these have to go away. But this tutorial shows them this basic. They hit export and they do an STL and they send that to me as a Google form. That's the basics of this. Now, the cool thing about Tinkercad is kids can manipulate something already done. I have them do the tutorials and I have them make a teacher pass using this. But if you go to Tinkercad, you can go in the gallery and find something already done. So like this train, if I click on this, now some will say copy and tinker. Some will say no derivatives, and we talk about copyright and we go through that. Like this person will let you print it, but you can't edit it. This, if you do this, they're letting us remix it. So whoever made this, now this is a pretty intense one, so it might take a little long. You'll see it actually loading all the different variables of it. I'm going to hit home some, and you can see, so they made this. So you could manipulate this. Now, some stuff, this train is all grouped together. If I want to manipulate that train, I have to ungroup it to get components to, like, say I want to change that to a different color. So yes, you can, but I have to manipulate it. And when I'm all done, I have to regroup it so that it stays together when I move. But kids can add to objects already done, and you could export them for 3D printing as well. So this is a great way for your levels, because some of your kids are going to fly and some kids are going to have a hard time. You can have some projects that are just, oh, add to this. That's kind of like the keychain is for my teacher. And that was all from the Tinkercad gallery. Now, so I've done some basics. Now, there's more detailed stuff right now, but that gives you the basic of Tinkercad. And if you do the 12 tutorials and you do the keychain and you have them make a keychain, you have them export it to you. Now, I've got a little bit of time, and I'm going to show you how do I get this file from Tinkercad to my printer. It goes from an STL or an OBJ, and it's got to become a G-code. G-code is slicing. Everything with 3D or a laser or anything is either cutting the layers, subtracting them away. That's your CNC, that's your laser. It's burning it away, it's cutting it away. Or it's adding to it, it's stacking the layers. So it has to have something that can slice all the layers. So you hit export and you export the file. So the file is down. Now I have a Google form that I just have the kids go and hand it into me. Now, then you have to have a slicer. Now, most programs come with built-in. Flashprint is the one that's made for a Flash Finder, the cheaper ones we buy. They have a Mac and a PC version. Cura comes from Ultimaker, and same thing, they have a Mac and a PC version. If you don't have that, KiriMoto, which I'll show you in a second, that is a web-based version. It's a little bit tougher to use, but if you don't have the PC or the Mac, you can use the KiriMoto. Flashprint now I've gone in Flashprint and set up to be my printer, to my work plane. So the printers we have here use it. So this is a 4x4 build plane, right? If I had a bigger one, then I would have to have it set up to there. I don't want to have my printer set up to the wrong one. So this Flashprint is set up. I went and set it up at the beginning. I went and here I picked the machine, and there's tons of, this is Flashboard software, so there's tons of the printers that are all here. This is set up for Finder 3 versus the regular Finder. So we have different size Finders. Now, if the older Finders, their panels are small. So as long as you're within the 4x4, you're okay. And if your newer Finder is big, it's when you try to take the 4x4 and you say, oh, I want to print it all the way on the 6x6, the printer will have a hard time. But you pick your printer, and it will make the print surface be there. You can see X, Y, and Z axis. Now over here, I'm just going to load file, and I went and downloaded. So this is a teacher pass that a kid made for me, and you can see we brought it in. Now, I cannot change, I'm not going to able to edit this. So I can't come in and change the Kelly or make this short or anything like that. I can do some simple things to it. Over here, I can move it. I can say on platform, and you want to do that. If you do this, see how it turns pink, or if I go too low, it will turn pink. That's telling you you're printing below the print surface. Or if I go this way, oh, the piece is too big, or it's printing off the surface. If I say center and on platform, it will make sure it's going to print on your platform. And you can kind of see there. Now, if I go and I can manipulate, so that's just moving it around. This will let you rotate it so you can spin it on its axis. Sometimes that's better for printing than other times. Sometimes you want to be able to print. You can see. Now, this is not going to be too bad, but if you have really overhanging stuff, you'd want to be careful of this. If you go surface to platform, it means it will make sure it's trying to do the best job to flatten it right onto your thing. Now you can see I wouldn't want to print like this because you see I have those ridges and I'm kind of floating. So I'm making my whole print job float. So I want to be careful of that. So I'm going to go level. And then I can do this. And so you can manipulate it, mess it around. If you turn that surface to platform off, you can do it. The problem when you start doing this, and again, it becomes, oh, if I'm trying to print, that's not going to be pretty fun to print. You can see it's floating in the air. You can see that's going to have a hard time, not a lot of surface. Now, I can come down here where it says supports, and I can turn on supports. I'm going to say auto supports. So this print job to work would have to print this material. Now, this is breakaway to when you're all done and a little here, but it would have to print that so that it's not too far of an angle. So the more you do, the more it would print. That's one style of print supports. If you go here and click on this, oh, yeah, I'm going to remove. If I use this style, tree supports, this is another version of supports. You can see, oh, it's showing out. You don't really need a lot. Again, I don't recommend, so I'm going to turn those rafts off, but I don't recommend, I recommend try to get as the best you can, okay, I'm just going to fix it. Actually, the best thing would be just delete it and bring it right back in. So file, load. And you can see I have it. Now the next one here below rotate, I can say scale. So I can say now uniform so if I say maximum, it will be the biggest it can be for your print platform. If I do change this, what it does is it's changed everything all at once. If I turn this off, it means you can do one axis. So if the Z, I wanted it to be thicker, I could make it thicker. If I wanted it to be wider, I could do just wideness, but notice I'm not changing the Y or the Z. Okay, hopefully that makes sense. Now, there's my part ready to go to print. There is a few things you can do. You can cut. Once in a while, kids will have extra material. So let's say you could see, so that's too long. I want to cut that. So if I move that and say start cut, you see I've made two pieces. I'm going to go back to move, get off this, but I can click on this and I can delete that extra piece. Now it's just arbitrary. It's just a sharp cut, but you can do a limited. I can't, that's the simple that I can change. That's cut. You can duplicate. The duplicate's nice because you can duplicate. So say you want multiple teacher passes. Well, what it's doing is it's showing you how many can I do on this surface. No, I can't do that. So you can see, and then I got to get rid of those. That's too many. It's going to mess up the print job if I have that. So you can see, oh, and I could print that many. I would be wary of trying to print multiples because what happens is you'll be printing, if one makes a mistake, then the whole thing is on. It's probably easier a lot of times just to print one at a time. All right. And the rest is, you can play around with this. We can print Wi-Fi, but this is pretty much basic. Now, when you got it ready, you say start slicing. Now, in the thing, it lets you play around with infills and things like that. And what that means is you can have your 3D print be solid. You can have it be hollow. I can say I want a raft. And a raft it adds an extra little brim to hold it down. Sometimes you have a really tall object or really curved edges like a bowl or something. You put rafting to help hold it down. Other is kind of cool too, because you can go in and find out to have two colors. So watch, I'm going to hit start slicing. So I'm going to hit slice. It's going to go and do the slicing, and it's going to tell you each slice. So I'm going to hit slice preview so we can see it. So if I drag it down, you can see it's going to do the rafting. Then it starts doing the honeycombing. So it's not printing it solid, it's honeycombing. Then it changes to just my name, and then it does the end. What I can do, so you can see right here, if I wanted to, if I told it to pause at 37, right? At 41, I'm sorry, at 41, I could have it be one color, and then it would change for the rest of the time to the rest of the colors. So this could be a two thing there. So if I hit close and I say start slicing, but this time under other, I say plus and I say pause it at step 41 and say, okay, when I hit slice, and I have that file, now what will happen on the printer, it will print one color, and at 41 it will pause, and you just, I have my kids unchange the color, so you can have 2-color ones and all of that. Then you just download the file and you have the G code to put on a thumb drive or send to your printer. And then you, whatever printer, that's how you do it. And this is Flashprint, but if I'm gonna, Cura is very similar to the Flashprint, but it's just its version of it. So similar things are the same. Now it's depending on what type of printer you have. We have Ultimakers that have dual extruders. So this Cura gives us the ability to have pick between 2 colors and have it jump between. Same idea, but this lets us do tool extruders and say, oh, if they use extruder 1, use this color. If they use extruder 2, same thing. We can come up here and say file, open a file. I'm going to grab a different teacher pass that I have. You can see this one is, see the letters there. Same thing. I can pause it. All the same settings. I can turn rafting off or on. Just a little different look, but it's the exact same thing as the Flashprint. I'm not going to go step by step through Cura. It's the same thing. If you need to, you don't have Cura, or can't have a PC or Mac, you can go here. And so I'm just going to go here, and if I type in KiriMoto, and it's KiriMoto, it's grid.space Cura. This opens up. It's a web-based version. Now, when you first open, it's default. So this plane is nowhere near what my printers are. So I have to go in setup and go machine and find my Flash Forge Finder or my Ultimate, whatever I have. I'm going to use this Finder one. I have to hit save. Now, I have found there's a little glitch. You'll hit save, and when you close it out, it will look like, oh, that looks the right size. But what I find is I literally have to close this out and open it back up again, and then it will be the right size. Then what I have is I can go, you can see there's one here. Same thing over here, infill. I can say I want it solid. There's some beautiful videos on this that you can step through and watch it. I can add supports. I can add my rafting, all of that here. I'm going to delete the sample. Files, I can say, okay, I'm going to import. Now, this is all web-based, so the kids are using, my students are using their Chromebooks. That's that thing we just, if you guys remember, we just made in thing. That's me importing it, right? Again, I can't really manipulate this. I can change its size, maybe. I can do stuff like that. So under tools, you can see I can rotate it. I could select it. I could scale it a little bit. So I can get in here and change the scale size of it. Type it. It's more typing based. Then I can, same thing, I can slice it. And you can see, and then I can go and look at it. Just like we talked about, again, same things as what we just did in Flashprint, but it's KiriMoto. It's just the web version. So one's Apple or Mac, one's Flashprint goes with the Flash Finders, Ultimate. Cura will work with anything. Flashprint will work with anything because it makes them as G codes. But now you can kind of see, I can down here, I can drag it, and we can actually watch the print. I talk to the kids too. This print is set up. See how soft, see how tight those honeycombs are? That's a pretty intense build. That will also take a long time to print. So we might want to go in and change the size of that infill. And you can actually see how the edges are print, what layer at 223 it starts doing the hello, that type of thing. So the kids, and again, there is no rafting on this, the kids can see it. But once you've got it sliced and you've got it how you want, you can go over here and say start, and you can say export. And now it will give you a G code file for this that, again, the kids can take over to the printer. So Tinkercad we use to either edit existing one, make our own. You can see now I can download, and I have a G code version of this file, not just, and I can play around with the settings. KiriMoto is a little bit more, a little less hand holding than the Flashprint and the Cura. Again, they're made for specific, so a little bit, but it's great for a web-based one. The biggest problem is making sure you have the right printer size. What kids will do is they won't change the size, and they'll have the big, huge one, and it will go over, and the printer will try to think, oh, I can print past this, and it can't. So that's something you just have to watch out for the kids. Now, so my kids' project, they do the process. They first you could just find stuff that's already printed. So they're just taking a customizer or going to Tinkercad and taking a gallery and finding something already done. Then prototyping is that next level, and I'll do a whole session on SketchUp because that would be its whole own thing. And then for my kids, they actually design their own house in 3D, and we actually go and print it. But it's another level. So you're actually prototyping. And then they start to produce real working things that it matters that the tolerance, like, so if we're building a drone, it matters how tight or small it is. And then we use tons of different programs. I will point out, Thingiverse is another place to find things already made. So you can see tons of stuff. Oh, it's carbon filter, and I can search stuff. Let's see, fidget cube. I have my students look for stuff that is useful and stuff that is cool. So fidget cube, and they go and find one and they say, oh, this one looks cool. And you can actually click on it and you can download it right into, get the STL, and then you can bring the file up and you could manipulate it in Tinkercad, that type of thing. So you can take those files, download them, use them back and forth. Tinkercad Gallery is a whole bunch of places where stuff's fine. Thingiverse is not a bad place to find things as well. OpenSCAD, which is, if that's a harder level one, that's actually reading the coding. It's like designing web pages like we used to have to do in HTML. So yeah, I have more power, but it's a lot harder to do versus using these other programs. But I just wanted to put it out there if you're there. So printers, flash, forge, finders, Ultimakers, Boot for Work, Slipper for Play. I'm not advocating one over the other. What I find as a teacher, it's not about, I could spend 3 or 4 and we have Ultimakers that have dual extruder and can do nylon and do some really fancy stuff. But what I find is it's not about having really good one printer. It's about having a whole bunch of printers. So I'd rather have a whole bunch of smaller, cheaper printers, because your value is not your product and even not the printer. It's the time. Print time is your commodity. So we do make it take. The kids make stuff for the school. And then they earn themselves print time. So once they've done a project, they earn themselves print time. So the kid's manufacturer. So I have a kid, he's done a nylon snowmobile. So an RC snowmobile that all works. So he applies his knowledge through his effort, and then we reiterate, we fix it and we test it and we see how it works. Because we tried to do this in PLA. Well, you put PLA and you put out in the snow, it's cornstarch, it's sugar, so it washes away. So that's why we're in the nylon. So science, they learn about the materials. Technology, they learn the modeling software. Materials, they have to learn about structure. Oh, if I do it out of PLA, yeah, it's gonna, if it has to be outside, that's not as good, or it's more rigid than ABS, or I might want to do the nylon. They read the technical manuals. Art, we talk about the design, the colors, the models, like what it looks like aesthetically. And math, we're doing scale measurements, X, Y, and Z axis. And I've done a whole video on this if you're interested. The PD4, which is right in the steammakers.education, goes through an overview of all of this. This session is more specifically to do Tinkercad and slicing, a little bit more detailed on that, so that you had a little bit better. So that was from my Learn from Necessity. I am going to do a couple more tutorial ones. So I'm going to go do a SketchUp one, and I'm going to do some my management classroom, Google Classroom, a Google Forms one. So like how to collect these files, and a video one around WeVideo and Flipgrid. And then I'll come back and I'll learn from consequences and talk about how we use a wood mill and how we make guitars and stuff. You have a Google form if you're interested. If you have feedback, so you're like, oh, hey, I really wish you would go and do this presentation, or I really would like to learn more about this tool, or you mentioned the simulation in Tinkercad. Could you do another session on that? So we will talk about, I'll come back. So we've talked a little bit about the slicers. We've talked about the Tinkercad and the design process. Now, again, there's more levels in Tinkercad. You can actually go in and I was showing you like designs, and I was showing you 3D design circuits. You can do circuit boards. Code blocks is kind of cool because you can, with code blocking, you can do the same thing. You're going and coding, but instead of you over here dragging and dropping, you're doing code blocks and adding to it. And what that means is, so this code block, you can see it's putting these shapes in and it's running a code to do it. So I can say, oh, I can control, repeat. So I'm going to put the shape in here and I'm going to say repeat. You can see, you can actually you can tell it to code. Like if I hit play, it's doing it, coding it on its own. So you can have it do like, oh, repeat this, make these 5 different blocks over and over and over again for me, that type of stuff. So you can get some really fancy things in Tinkercad. I haven't even played with the simulator as much. And they offer challenges. The classroom's kind of cool. They have like lessons in here too. So for example, you can have the kids on their own do these. So they go in the classroom, oh, create a piece of skatable art. So they create this and then the skateboard runs around and skates on the object. We scroll down, design your own dream room. I had the kids doing that. So there's kind of some cool lessons that are all built already in there. And if you go in, they, again, they could do it on their own. They don't need to babysit you. Now, again, in my website, these will all be here. If you click on one, so you click on the Learn from Necessity, in here is my description, here's videos, here's the slide deck. I'm going to add this video to tutorial videos, and I'm going to go back and add more detail. So if at any time you're like, oh, okay, I want to learn more, that's there. I am working on adding the curriculum. So I'm going to go step by step, kind of what the curriculum is, what I did in the 5th grade, learn from success, and I'm working my way down, and I'll be updating it as I go. So you can kind of have a curriculum around, and you could pick and choose what things fit your class, your school. If I go here, I've also over here added, there is a newsletter. So, and you can also sign up. So I keep putting basically, in a month, I'm trying to put 2 or 3 a month, depending on what I present. Usually it's one's about what I'm going to present and it leads you things. But I also try to go down and give you like, oh, here's where I get some grants. Here's some money. State is doing a new grant round here. So I put that all in there. That's coming up. So you can apply. And I have tons of these that will be there. There's also a mail newsletter that you can sign up for, so you can get this newsletter in your mailbox. I've added a resource link page, so resources, so grants, and where I find Harbor Freight gives $200, Maine Ag in the Classroom, I've got a couple grand from there, some challenges that are out there, some resources like Harold Alphon Center that gives out funding for training. Last year I had 20 teachers get a free 3D printer and got to do a whole course on that. Different kind of things that I like, the books I like to read, things like that. So that's all there. And then there's a little bit about me if you just want some like contact information. That's all on the website. And everything that I just did today will all be there. That's my plan. My next session I plan on in December, because this is November's. I'm going to try to do a 3D around SketchUp and how to use this to make things. You can make STL files that can be printed from this too, but this kind of goes to another level of actually modeling and testing. Like when I did my classroom, so when we moved into our new building, I did a test around, or like I teach the kids how to go and like work on like their own houses in 3D. I'm going to do this next session, but I'm just gonna so the kids learn how they manipulate a 3D object and kind of make their own stuff, that type of thing. And I'll show you guys how this is all done in a session on its own. That's the next session that will be coming up if you're interested. So we're almost done. Thank you guys very much. If you have any questions, feel free to contact me.